Great. Well, thank you for the introduction. Again, this is Kevin Dunn with QA Symphony, and I'm very excited today to talk about this particular topic. One of the things that we study very closely in the market is the trends that are driving software development so that we can kind of incorporate those into the products that we build to serve our customers in the market. And so we've been really closely following a lot of the major trends this year. And in doing so, we've come up with some strategies that we think our customers and prospects and colleagues can leverage to help them to attain quality at scale. So specifically, it's always important to manage quality and to have specifically good focus on building software that maintains quality as you move towards DevOps and move towards Agile and more rapid delivery. But we want to focus specifically on the strategies here for maintaining that quality for large enterprises that are trying to do this at scale. So I wanted to start off here with a quote just to give some perspective. This is a quote from unknown contributor, but here it says, "Quality is never an accident. It is always the result of high intention, sincere effort, intelligent direction, and skillful execution. It represents the wise choice of many alternatives." So I think this is important to keep in mind here. A lot of companies lose sight on what quality really is, and they kind of mistake testing and running a lot of tests, performing a lot of tests as having high quality. It's important to understand that these two things are separate. So tests are certainly something that can help you to drive higher quality in your application, but testing on its own does not guarantee high quality. The second quote we have here is another one that just shows the importance of quality. So we know that quality, is something that we need to focus on, and it takes specific effort to drive high quality in these applications. This quote from Gardner here is explaining the importance of quality as we move towards DevOps and Agile initiatives. So here it's saying the extension from Agile and continuous integration to continuous delivery and utilization of DevOps concepts relies on the ability to drive continuous quality. So here we kind of understand, that quality specifically is something that's going to take some real effort to drive. We're going to need to have some strategies around it, but it is important. It's important specifically for companies that are trying to adopt Agile and eventually DevOps. And third piece here I would mention as well is that everything becomes more complex at scale. So the larger the organization you have, the more complex managing these activities is going to be. That's just the nature of kind of the stakes in enterprise software development. So to tie back into the theme from the beginning here, these are really the 5 major themes that we're going to cover on today, 5 of many other themes driving change and acceleration in the software development ecosystem. Specifically here, we're going to touch today on specialization, cloud hosting, architectural shifts, collaboration, and ease of use and deployment. So for each of these, we'll walk through this and we'll explain to you, if you're not familiar with these terms, what each of these trends really is, why it's happening. So what's the kind of underlying cause of these trends becoming popular specifically now and today. And then we'll talk about what that means for testing, what's the impact, and then what's a strategy that we can take back to our teams so that not only do we kind of mitigate the risk of falling behind due to any of these shifts, but actually we can position ourselves to take advantage of these shifts and potentially even drive higher quality than we were previously. So we'll start here with the first trend, which is specialization. So to walk through here what specialization is, it's really this drive and initiative towards allowing companies to use multiple development frameworks, whether that's using JavaScript as well as Java, as well as maybe some .NET in different parts of the organization, kind of breaking apart these typically standardized processes of using a single framework across an entire application and moving towards many more diverse frameworks, specifically for the UI development across different teams. And one of the reasons why we think this is happening is actually adopting of microservices. So because of companies that are adopting microservices to allow for easy communication between applications at sort of an API level, it allows the applications to talk to each other without having to actually share the same code base. And a lot of this is being driven by the ability or the need for customers to be able to perform different activities across different interface of different channels. So maybe having a mobile app versus a web app versus maybe a desktop app that's used internally. So, this drive towards microservices kind of decouples the applications. And what that means is that each team can kind of make their own choice on which language they want to use based on, what might be most familiar to the developers on the team, what's best for the specific device they're creating an application for. And that means that there's a number of different frameworks being used across organizations. And it affects testing because all the testers need to be familiar with these different types of frameworks, and they need to get specifically automated UI testing tools and other automated testing tools that interact with those specific frameworks. And so that means the number of testing tools grows as well. And as that grows, the impact of that is that testers, need to either choose one specific framework and specialize around understanding the tools that work with that framework, sort of limits the number of teams that they can be useful in and their ability to work across different teams, or they are limited in how deep they can go with a particular tool. So they instead have to become very broad and try to be an expert on 5 or 10 or 20 different testing tools, which makes it very difficult for them to become experts in any particular area. And so one of the major drivers of this kind of growth in frameworks and therefore UI testing tools is the adoption of JavaScript. So JavaScript's become very popular. A lot of the most forward-thinking companies in software development, like Netflix and Google, and others like Facebook, are adopting these different sort of JavaScript front-end frameworks. And these frameworks, there's a number of different ones, all different flavors. People might use several in an organization, or even one particular application or team might use several within there. And within a typical JavaScript application, there's a need for diverse UI testing tools, as well as integration testing tools, even unit testing tools, depending on the language being used. So the number of tools, for just one particular application, one particular UI framework for testing could be 3 or 4 tools per framework. And we're showing an example of that here. Depending on what JavaScript framework is chosen, you may end up with a number of different tools that are being used as test runner, the actual library, the actual framework. The number of tools grows exponentially. So you can see how very easily a tester might go from, in the past, only needing to know how to use maybe HPUFT, and that's a single automation tool in-house, to now, with the shift towards multiple UI frameworks, multiple testing tools, they're now responsible for maybe knowing 10 or 20 different tools, which becomes very burdensome for them. So what can we do about this? How can we help to solve this particular problem and address this trend in the market? One thing we think that will keep everyone honest is to have developers more involved in the testing. So developers often make these choices about adding new UI frameworks, starting a project in a new UI framework that no other team has used, kind of in a vacuum, forcing them to be the people that contribute some of the tests and forcing them to have some skin in the game about making that choice will make them think twice about whether or not it's really needed to add another framework into the organization stack, and that will help to limit the number of frameworks hopefully out there in the first place. Testing lower in the testing pyramid, to go back to this slide here, and driving some more of the tests to the unit or integration level. A lot of these tools are not specific to a particular UI framework, so the more tests that can be done down here will drive more sort of efficiency and reuse of tools, reuse of tests, etc. And then the third piece of advice we have here is just to be sensible about automation. So make sure that anything that you're deciding to automate is going to give you payback. So look at, hey, how many times are we going to run this test? What's the cost of me automating this the first time? Plus, what's the cost of me maintaining that automation ongoing? And if this is a script that changes particularly often because the UI, for example, changes quite frequently and the test needs to be maintained a lot, look at what are the actual time savings of me automating that test, and also look at what's the value of running that test in general. Is that a valuable test? The goal is not to have as many tests as possible. It's to try to achieve good test coverage with as few tests as possible to limit the amount of maintenance that needs to be done. So just being sensible about automation in general can help to solve a lot of these problems. The next trend that we'll cover here is cloud hosting. So I think most people are familiar with cloud hosting, but many applications, infrastructure for development are moving their hosting towards public or private clouds. Oftentimes they're provided by companies like Amazon, Google, Microsoft, etc. And I think it's pretty straightforward why this trend is occurring, at least in many of the industries where it is possible. And it's really because it allows you to get your hands on a number of different resources, a large pool of resources at a relatively low cost. So you can kind of elastically scale your applications. You don't need to buy 100 servers if you typically only use 10, and on Christmas Day you happen to use 100. You can use a more elastic scaling model, which allows you to not have to own all of those servers outright for all the other days of the year. And so how it affects testing is that we have specific new challenges now with these cloud-hosted apps. And they can be accessed anywhere around the world. They can be accessed through a number of different browsers. There's thousands or millions of users that can get into these particular applications. And for a lot of companies, this is their first time thinking about a lot of these problems and needing to write tests that accommodate for these specific challenges. So here we see kind of the growth, in these different segments. It's undeniable that people are moving applications towards the cloud. Almost 50% growth year over year in Amazon and Microsoft's, cloud infrastructure, which is a lot of the hosting that companies use for those cloud applications in production. Also, the sort of pre-production testing and QA development environments that they may use up to the point that they do a release. So if your company's chosen to use these cloud hosting services and go towards a cloud app model, there's going to be some challenges that may be new to your organization that come with that. One specific one is performance. So, as the software scales and you want to take advantage of that kind of elastic scaling capability where the application spins up more servers as more users try to access the system, that's going to be a typical failure point where you need to test that, all throughout the scale from 0 users up to maybe thousands or millions of users you might expect, that the application doesn't slow down and that's kind of a smooth process. And so for a lot of those tests, it's going to be very difficult to run that manually with your typical infrastructure. You're going to need specific tools that automate that process. So that's one thing to take into consideration. Another thing is just testing that the application actually works, because you're deploying a lot of components into the cloud. It's not your own infrastructure. Things could constantly be changing in the cloud. It's worthwhile as you release, and you're doing very frequent releases to the cloud and DevOps, that you're either running automated tests and or monitoring to make sure that everything's working as it should. And if it's not, that you're able to make changes or roll back specific releases that you push out. And then finally, compatibility. So because we're moving to a cloud app model, the browser becomes kind of the client for the application. There's obviously a number of browsers out there just for desktop, and then you've got all the mobile web problems to deal with as well, and concerns there. So a lot of companies are trying to figure out how to really automate that process of validating that the application experience is the same across different browsers. And so our advice is really to kind of fight fire with fire, so to speak, and use the cloud as a way and a means to solve some of these specific cloud hosting problems. So on the performance side, if you want to test scalability, use something like a Blaze meter that allows you to generate demand and performance tests across your application at different levels at very low cost relatively. On a functional testing side, if you want to make sure that your application's working properly, especially across different browsers, you could use something like a Sauce Labs or a browser stack to run a number of automated tests quickly to get quick validation that your application is actually running well, or if there's problems identified, that you can sort of go and roll back that release or fix whatever it is if it's an easy fix to make to the application. And then on sort of the broader scale, as you try to test across a number of different networks, devices, for example, browsers that you may not have easy access to. Things like Applause, for example, would allow you to get quick feedback on your web app from people all around the world with all different types of devices. They can let you know specific problems that they're having to their current kind of configuration that they're accessing the application with. And it becomes oftentimes a cheap and easy way to get a lot of feedback on how well your app works sort of around the globe. A new topic that's become a very top of mind for many of our customers is kind of this architectural shift, specifically towards building applications with a service-oriented architecture, or SOA. And so what this is really talking about is sort of a drive towards, like we mentioned earlier, microservices, and breaking up these typically large monolithic applications into much smaller components that speak to each other through these application program interfaces. And it's happening because as companies want to break down into these agile teams and be able to have their own independent release schedules, independent planning schedules, independent DevOps pipelines. It's driving teams towards breaking up their application into smaller pieces that can act independently. The code inside those small applications can change, and those application program interfaces can stay more constant. So the other applications within that ecosystem can rely on the API to be constant, while the other code behind that API may be changing. And it affects testing because most people aren't doing really good API testing today. They sort of ignore that and do a lot of the testing at sort of the UI or the unit level. And this drives the need for people to really have a holistic test strategy that includes API testing. So you can see here kind of the shift from these large monolithic applications, where all this code is commingled together and connecting to different data repositories, into these sort of smaller pieces that are reusable inside of these composite applications. And the benefits of this, for Agile and DevOps teams, is that you sort of separate the logic. You kind of have very discrete units that act as teams, and they can more easily connect to each other and quickly build, say, mobile applications that draw on the same data as the desktop application without having to be on the same release schedule as the desktop application. That would be oftentimes very prohibitive. They can have their own release cycles, their own deployment pipelines, and it allows them to very easily build APIs that can help them integrate to the outside world. So as they build more and more APIs that communicate internally, they can also connect to external APIs, make sure that their service connects out to all of those other third-party applications and things that are becoming increasingly popular in today's development ecosystem. So Netflix is an example of a company that's really embraced this methodology. You can see here, this is a diagram that's taken at some point of kind of the Netflix microservices and all of the different calls that happen in between the services that run in Netflix. So each of these is kind of a miniaturized application that's running and communicating with other applications within what we know as Netflix, which seems to just be one application, but it's also got all these hundreds of services running under the hood that are all connected through APIs. And so APIs really change the game from a typical UI test, where we're looking for much different things in the UI test about how the application interface is presented to us, how responsive it is, how it deals with us inputting information and responds accordingly. API testing is going to be different. Really, it's a call and response. You're going to send a certain set of data and get hopefully a response back that matches the pattern that you're looking for. And so rather than worrying about some of the traditional things that UI tests test for, what we're looking for is really three things with an API test. It's uptime. So as we run a test consistently, how often is the API not responding at all? That will obviously cause downstream impacts in the application. You have accuracy. So when we send a call to the API, do we get the response we expect? We could get a response and it may not be the one that we expect. That may cause errors in our application. If we search for a specific customer ID, get back the wrong name, we may think it's a bug in our application code. It may actually be an issue with an API we're calling from another part of the application, and that may not actually be our fault at all. And then latency. So how quickly does the API respond? Sometimes it's not an uptime problem. The API is responding. It's just taking a long time. And sometimes when the API calls take too long, it's actually just as bad as not getting a response at all, because the application sort of moved on and expected that it's not getting any response at all. So the late response is never really registered in the code. Collaboration is obviously key. You'll hear Atlassian talking a big game about all of the new collaboration tools that they have. Some existing tools as well, things like Confluence, HipChat, etc. So collaboration is obviously top of mind for organizations doing Agile and DevOps. As teams work in smaller and smaller groups to fit into that agile model, they need to be able to communicate very quickly within those teams, but we also need to be able to have teams share knowledge with each other. And then as organizational level, we need to be able to kind of report and centralize across all of the different departments that those teams might be in. And the problem becomes more and more complex as teams work towards distributed models. We may have people working around the globe, working remotely, etc. And again, Agile is really the driver of this, but there's some other things at hand here. Globalization of organizations across the world. They've got teams or individuals working everywhere around the world that need to be able to contribute and collaborate. And the technology is really allowing us to do this, whereas in the past we didn't have good tools for this. Now there's a wealth of tools. So the problem really becomes trying to pick the right tool, out of the hundreds of thousands that are out there today. And for testers, a lot of times, because testers were used to working in a large siloed testing team, now they're working as an embedded tester within a more product focused agile delivery team. They need to learn how to use these new tools like Jira, Confluence, Bitbucket, etc. They also need to learn how to integrate their work and what they're doing with testing into those tools so that others on the team can see what they're up to and what they're doing. And one of the companies that's really driving this collaboration, across the globe is GitLab. So they are an agile team that develops agile software that helps teams to kind of track their developments in a similar way to Jira. And they've posted this Remote Manifesto and actually have a remote-only culture. So it's specifically just the tools, whether those be web conferencing tools, tracking tools like Jira, Confluence, etc., Slack, HipChat. Those are the only ways that they have for communication. They actually don't have any scheduled in-person communication. They don't have any dedicated office space where people can work together. So they're actually relying on these tools 100% to allow for that collaboration and agile development. And so, tools obviously seem like the answer to the problem, but as you can see here, there are thousands of tools out on the market. This is just a subsegment that we put together and highlighted here at QA Symphony, just looking at tools specific to the SDLC that help with sort of collaboration inside of Agile development. So a number of different tools in different categories. You could, spend years just trying to find the tools that you need to get your team running, and you never get any work done. So, collaboration, obviously a lot of it comes down to culture, but some of it comes down to tools as well. Some of the features that we recommend that companies look at when evaluating collaboration tools is one, ease of adoption. So, people have a lot of tools to use today. They're difficult to use. People don't really have the time to invest in becoming an expert in a tool if it takes, weeks or months. They want to be able to get into it in minutes and kind of start to add value. So ease of adoption is key. Real-time information sharing, things like HipChat and Slack become very important because in Agile and DevOps, we're releasing maybe every minute or every hour, and we need to know right away if there's a problem so we can fix it. And so real-time capabilities become increasingly important. Flexibility. So we want to be able to standardize where possible on a single tool, but we don't want the tool to define the way that teams need to work. There may be teams that need to work in different ways, within an organization depending on what they're working on. So flexibility becomes very important so that we can have a single tool across the enterprise in a category that supports multiple different teams working in different ways. And then integrated, obviously, if we have, dozens of tools, and going back to the diagram I showed, they need to all be able to integrate so that they're speaking to one another, and the testers within a team are able to feed their information to development and so on. Now, the final trend that we'll touch on here today is sort of deployment and ease of setup, ease of use. And this ties in really to containers. So many of you may have heard of a company called Docker, which is one of the four, forward thought leaders in the new space of containers, which is really kind of redefining the way that we virtualize infrastructure, moving from VMs previously to this new container model. And a lot of this is being driven by the cloud adoption that we spoke about on earlier slides, a number of resources being consumed in the cloud and people trying to make those be used as efficiently as possible. Although containers can be used in any environment, it doesn't have to be a public cloud. It could be used on servers internally or even your own personal desktop if you wanted to do that. And it affects testing because actually there's a great benefit that we're able to now create testing environments very easily, where it used to take maybe days or weeks or months to get a new test environment set up with the current version of the code. With today's technology, including a lot of the DevOps pipeline things and containers at the back end, we can actually deploy testing environments in maybe minutes or hours, which allows you to do testing much more quickly after code has been developed, which we'll show is a big benefit to everyone on our teams. So this is just highlighting here some of the extreme growth that we have in containers and adoption here over just the course of the last 3 or 4 years. You'll see that it's really grown exponentially here in terms of the number of containers that are being used within different organizations. And a container really, again, is just a more efficient way of packaging up your software and allowing it to run on your infrastructure, whether that's internal infrastructure or something out in the cloud. And that's because it's really acting as, sort of a shipping container. You packaging up all the elements of an application, you're putting it in a container, and that container can run the same on sort of a development machine, your own personal laptop, as well as out in the public cloud. So it's kind of it's agnostic to the type of infrastructure it's running on, just brings all of the components and runs them very efficiently on a machine, and that allows it to be, it's easy to package up the current version of an application, very easy to get it running in a QA environment, for example, so we can get up and get testing on the latest code very quickly. And what this allows us to do is really shift left with our testing. So rather than doing the testing later in the cycle here, where we're kind of towards the final release and end of the project, instead what we do is shift the testing up front. So it's more integrated with kind of the planning and early development process. Shift left testing is a big benefit for organizations because it's statistically shown that the earlier you find a bug, the cheaper it is to resolve. It could cost 100 times more to fix a bug found in production or right before production versus one found early on in sort of a planning or early development phase. And a lot of that is because it's much cheaper, from a resource perspective to do those fixes, because you don't have to get whole operations team involved in rolling back a production environment. Also, you don't have any outages for customers using production systems that may have an additional cost. And also the developer has just recently worked on that code. So the earlier you can have him or her go back and fix that problem, the more recent it is in their memory, and probably easier it will be for them to make a quick edit there and then update the code. So for all those reasons, it's great for us to adopt containers, and then in adopting containers, try to take those benefits and shift the testing that we're doing earlier in the process. So that's all we had for today. Again, we see these as 5 of the major trends shaping the way that development teams are working here in 2017, specifically the ones that are adopting Agile and DevOps. we believe and will always believe that quality is a very important piece to building any application, and it's certainly important to having success in DevOps and Agile. So if you believe like us that these trends are some of the key ones shaping the way that we are developing today's software, we would urge you to take some of these strategies and recommendations and see how you can apply them to your team to make sure that you're able to continue to drive quality at scale in your enterprise application development. So with that, we've received a lot of good questions here, and we're going to open this up for you guys to submit some more questions and get to answering those here soon. Thank you very much and appreciate all of your time today.